So we take data from various parts of the infrastructure, switches, firewalls, routers, load balancers, servers, physical or virtual, as well as from public cloud, SD-WAN, software-defined networking, data sources, data lakes. And we take this data using homegrown ingestion pipeline. We'll get into it more in our deep dive, which is highly scalable and very, very cost effective. So we have built SNMP ingestion. Some people will be surprised to hear that. Here we are a very modern company. Why are we doing SNMP? Well, it turns out, most of you know better than us, that literally every network out there has a large SNMP deployment. So to work with these networks, you sort of have to really deal with SNMP. But then to take these networks to the next generation architectures, we have very, very optimized implementations for gRPC, GNMI, OpenConfig. We have a ton of syslog technology. We'll talk a lot about that today. Very proprietary, cutting edge technology around finding anomalies from syslog. We also do a lot with flow data. So we have integrations with SFlow, IPFix, even VPC flow logs, something which we added last quarter. We have our own API, which can be used for feeding us a lot of proprietary data as well as topology data. And we can take data from Kafka. To complement all of this, we have our own agent. And this can be deployed. It's a Linux agent. It can be deployed on VMs, on servers, even on switches, actually, as long as a Linux agent can be deployed on a switch. And it really enables latency and loss measurement to provide end-to-end SLA, which is very complementary data. What is not listed on the slide is TWAMP, which is another example of loss latency data. We have off-the-shelf integration with TWAMP as well. All this comes into our network AI engine. And this engine comprises 9 and growing number of proprietary algorithms, which are really a result of very specialized R&D over many years. This is across anomaly detection, both metric-based anomaly detection over hundreds of metrics, as well as log-based anomaly detection. Then we have the ability to automatically learn the model of the network. So we auto-discover the constructs in the network, whether it is in data center, in WAN, in SD-WAN, not just the routing protocols, but if there is a line card on a switch or a router, and there are queues on that, we discover all these constructs. And we use these building blocks to then do autocorrelation, again, using a machine learning algorithm. We are seeing significant outcomes of our technology. Some very large operators have spoken about that recently in a couple of conferences. You can look up AINet from April, ONUG, just last week, and they're seeing significant results, in terms of reducing outages, significant reduction in detection times, and so on. And our workflows can be consumed by various teams, all the way from NetOps, NetSecOps, CloudOps, and automated workflows. This part is very important. So we plug in directly into ServiceNow. We plug into Slack, syslog. We can emit syslog-based alerts. So the output of our platform can really be consumed in a very proactive way.